Heyo students, AP Stat students, happy Monday everyone. I hope you watch this video before you come to class on Monday. We're going to be jumping into chapter 12, talking about different ways of sampling and biases that may come up. Okay. So for this week, there is an optional practice assignment. It'd be good practice for you to get ready for your first quiz on on Thursday. So this assignment I will not be collecting. However, we'll be going over it in class, okay? So at the end of each class period on Tuesday and Thursday, we'll be going over this, or Thursday before your quiz, we'll be going over this too. So I think it's definitely to your advantage to get it done, okay? All right. So today what we're gonna be talking about is different ways of sampling and then what sampling actually means. I think you already know what that means. And then Tuesday, we'll be talking about different types of biases. So I listed some page numbers. So right now, if you want to turn your books to 270, we will get started right there. Okay. So the first thing we need to talk about is what is the difference between a population and a sample? And I wanted to demonstrate this using a food analogy, because who doesn't like food? So let's pretend, I have this pot right here. You can't really quite see the pot, it's kind of too big, but I have this big pot right here, and I'm gonna be making chili. Class, did you know that I'm a world-class chili cooker? Okay, so I make one of the world's best chili, says myself. In my chili, I put all sorts of different things. Of course, you have the beans, you have your ground beef, you have your onions, and there's some other things in there that I put in that I can't quite tell you because it's a family recipe passed down from generation to generation. Okay, so when I think about this chili, right? When I make it, I always want to make sure it tastes okay. Okay, so how am I going to taste to see that it tastes okay? I'm going to take a little, you guessed it, a sample, right? I'm gonna take my spoon, dig it in there, and taste a little bit of it. Here, I'll let you taste a little bit. Right. So, of course, I would not eat the whole thing. So, your little taste is what we call your little sample. So when you think about the population, think of that as the entire pot, okay? The entire pot or whatever that you're gonna be tasting. And then this is just your little spoon that you're tasting. Okay. If you do it right, this should give you a good idea of that. Class, right? If I wanted to know how my chili tasted, I would not taste the entire pot. I would not eat the whole thing. There wouldn't be any more for anyone else. Right? I would just take a little bit. And that's what we want to do in statistics. When we're trying to make a claim about an entire population, of course, we're not going to ask the whole population how they think about something. We're not going to survey the entire population. That would just take too much time, too much money, and is really, really not, almost even impossible to do. So we take a little sample, okay? So for instance, if I were to ask, how do Americans feel about same-sex marriage? Okay? I could not go to every single American and ask him or her, how do you feel? Right? I would have to take a sample. So you could probably start thinking right now, what would be the best way to sample that? Should I just stand on the street corner outside Marshall Fundamental and ask people how they feel? Would that be representative? And that's another term, right, that we need to know. Is this term, representative? This is a really key idea. You want to make sure your spoon, your sample, is representative of the entire pot or the population, okay? So there's some other terms that go along with this that you'll see. You'll see something called a statistic, okay? And then you'll also see something called a sample statistic. These two things mean exactly the same, okay? And then for here, you'll see something called a parameter, and then you also see something called a population parameter. These two are the exact same thing, okay? So when you look in your textbook, you'll see it worded in different manners. Okay. So if you want more information on this, please see page 275, especially read that green box right there. A lot of times we won't know what population parameters are, so that's why we take a sample statistic to make a guess, an estimated, an educated guess about a population. Okay, so again, your pot is your population, your spoon, your sampling spoon is your sample. And from this spoon, I'm gonna make a statistic out of this spoon. All right, so what would be a good way to sample this? All right. So on the first page of the chapter, page 270, it goes through three parts or three ideas that produce a good sample statistic. And the first thing is you have to examine a part of the whole, all right? So this may sound ridiculous. If I wanted to see how my pot of chili tastes, right? I would take my spoon and I would sample this pot of chili. I would not go over to my neighbor's and sample his or her pot of chili, or the pot of chili, you know, from my grandma, or the one my little sister made, right? If I want to make a claim about this chili right here, I would sample this one. So it's kind of like duh, right? You examine a part of the whole you're trying to make a claim of. So I'm going to write a little duh, or okay. So of course, the second idea here is you have to really, really randomize. Okay. So I'll tell you one little secret of my chili. Okay, so yes, ground beef, onions, those are always good in there, you know, but another thing that I like, and some people may think it's strange, but I like to put corn in my chili. I feel like the crunch of corn, that sweetness, that textural change is like what separates my chili from the rest of the world. Right? And also the beans you put into chili. So some of you might think that all beans are the same, right? But there's so many different types of beans. Go Google it right now. There are black beans, red beans, and within those black and red beans are different types. You have pinto beans, cannellini, you have fava beans, you have soybeans, mung beans. Of course, not all these type of beans go into chili, but really, you can put in whatever bean you want. But what if I put in my corn first, and then I put in my fava beans, and then my white beans, and then my great northern beans, right, and then my ground beef, and I just made these layers like a cake, okay, and then I decided to sample it. Would that be a good way of sampling? No, right? What I would need to do is I need to get my spatula and mix it all together, okay? So in cooking, that's called mixing, but in statistics, we call that randomizing. You gotta mix the pot together, okay? So the third idea is a sample size. So you wanna get a proper sample size, and we use sample size a lot in statistics, and we like to abbreviate this as SS, okay, your sample size. The general rule of thumb is that a sample is approximately 10% of the population, okay? Of course, this is not always possible, right? In the United States right now, what do we have, like 300 something million, I think, 300 something million. So 10% of that would be 30 million. To make a claim about the United States, having to survey 30 million people to make a claim about 300 million people would be pretty difficult, pretty time consuming. So this is ideal. However, you want something less, like less than 10% is okay. Same thing with your pot of chili. If this pot of chili is filled to the top and we want 10% of this, that's a lot of chili you gotta sample, right? So the rule of thumb is 10% or less, okay? And generally it's gonna be less, but if it's a little bit more, it's okay. It's okay. Okay, again, it's a general rule of thumb. All right, so let's talk about now ways to sample. So sampling methods. And I hope that you're following along in your textbook, and I'm going to give you some page numbers we're going to start with. We're going to start on page 276. Oh, by the way, for here, I want you to take a look at, see the symbols on top of page 276, okay? Those are symbols we're going to be using a lot throughout the year. Right now, we haven't talked about most of those, but maybe put a little sticky note or a little tab on page 276 so you know what those symbols mean. And those come up later. Okay. So for sampling methods, there are really 5 different sampling methods, really 5 good ones, and then a 6th one, convenience sampling, which is not very good. The first one we call is a simple random sample. Okay, a simple random sample is where you randomize your population and then you simply sample it. Okay, so what we have been doing in class, right? We've been using our calculator to randomize and pick a student. So this would be a type of simple random sample. Okay, so I can use this and I can call on students. Because really what I'm trying to do, class, when I call on you in class, I'm trying to see, I call on 1 student or 2 students, and I want to see if that 1 or 2 students understand what I'm talking about. I'm trying to make I'm trying to see if the rest of the class knows what I'm talking about. Obviously, I cannot ask all of you, do you know this stuff, right? So I call on 1 or 2 or 3 of you as a sample to represent the entire class, which is the population. Something else we've been doing, I did this for my other classes, is I took a popsicle stick. It took me a while to eat a lot of popsicles over the summer, and I just wrote the names of each student on the stick. So when I shake it up, right, this is the randomizing process, and if I pick a name, that is my sample. So these 3 students could be my sample that represents the entire population. Okay. So the next type is what we called stratified random sampling. And I'm going to cover this one and the 3rd one more in class on Monday, because those 2 are probably the most difficult ones to go over. This is where you separate your population into different groups, into what we call strata in statistics. And you want to make sure that you take a little bit of each strata in your sample. So for example, let's say I wanted to know what is the favorite color of Marshall students. Okay, what is the favorite color of Marshall students? And let's say I'm lazy and I just wanted to ask all of you. So everyone in AP Stats, I ask all of you, what is your favorite color? I come up with a consensus, or I come up with the highest chosen color, and I say, okay, that color represents the favorite color of Marshall. No, right? Of course not. I would have to ensure that I get some responses from 6th graders and 7th graders and 8th, 9th, 10th, 11, 12, right? So what I'm doing is, if I have, if I want to make a claim about Marshall students, I want to separate into 6th, 7th, 8th, 9th, 10th, and so on. And I want to separate these like this, right? So each of the students are in, here, I don't know how many students there are in each one, okay? And then I want to make sure that when I take my sample, I get a little bit of each layer, okay? The way I think about this is kind of like cake, right? Class, type in the comment section, what's your favorite type of cake? So I'm a fan of chocolate cake. I like chocolate cake, like the type of chocolate cake where you need some milk. Like you cannot ingest it without milk. That's what I'm talking about, okay? And I like it with multiple layers. Cake, cream, cake, more cream, cake. And then what I love to do, if you ever been to, what's that place like where the miners go? Oh my gosh. Oh my, I cannot think of it. It's on Huntington and Arcadia. Claim Jumper. Claim Jumper. They have this cake, right, that's like this tall. You can Google it. And if I took my spoon and I cut from the top to the bottom, I get a little bit of each layer, right? I'm getting a little bit of each strata. That would be stratified random sampling. Think about that next time you have some cake. The third one is cluster sampling, okay? So cluster sampling is where you don't separate your population like you did in stratified random sampling. Rather, you try to find an already existing group to use as a cluster. So the main thing that we need to know is the difference between a strata and a cluster. On the bottom of page 278, there is a green box. Read that. That will be helpful for you. Let's say I wanted to go back and figure out what is the favorite color of Marshall. And I don't have time to separate the school into different grade levels. So I'm looking for a class that has most of the grade levels represented in it. Okay? Obviously, I wouldn't go to AP Statistics because it's mainly seniors with a sprinkling of some juniors. I wouldn't go to your English 4 class or ERWC because that's what seniors. I wouldn't go to, the Math 1 math class because that's mainly freshmen. I would look for something like maybe orchestra, right? Orchestra, if I'm not mistaken, has students from 6 to 12, or maybe I'll go look at the drama class. I think some of those classes are, you have a wide range. So that's an already existing group that is an already existing cluster, okay? Again, we'll talk more about this on Monday, but I'm trying to give you something to work with. The fourth one is multistage. Multistage sampling just means that you use one or more of these methods, okay? So it's totally fine if you, for example, you take a cluster and then that cluster you take a simple random sample of it. So that would be considered multi-stage sampling with cluster and a simple random sample. We abbreviate simple random samples as SRS because it's really long to say. And lastly is systematic sampling. Okay. Let's go back to our example. We wanted to see what color was the favorite Marshall students. Let's say this was non-COVID-19 time right now, and students were walking into school, and I wait at the front of the school, and I systematically select people to sample. So let's say every 5th person that walks by me, I ask them, hey, what is your favorite color? Okay? And if I kept doing that for, I don't know, for an hour, right, before school started, I would think that I would get a pretty good representative, there's that word again, representative, sample of Marshall's population. Okay? However, there's a chance, even with systematic sampling, class, think about this. If I sampled every 5th person to walk by me at the front of school to ask, what is your favorite color? Is it possible that I somehow get all seniors still? Highly improbable, but probably. Is it possible that I don't get any middle school students and I only get 9th through 12th graders? Again, probably won't happen, but it is definitely possible, right? So systematic is good. All of these are good. However, there's always like a downside, and that's where we talk about biases, which we'll talk about on Tuesday. Okay. The last thing I want to do with you is I want you to go to the just checking on page 279. Okay. These are really, really good. These kind of check to see if you understand what you're reading. So as you read your textbook, I would definitely stop in and answer these questions. The answers are always at end of the chapter. So in our case, it's on the very last page after the question. So on page 292. Okay. You can check right there on page 292. So this one says, we need to survey a random sample of 300 passengers on a flight from San Francisco to Tokyo. Name each sampling method described below. What I'm going to do right now is I'm going to draw an airplane, okay? Don't laugh. Let's see. So we have a chair right there. So these are all seats. You can fast forward through this part if you want. If you're making fun of my drawing, I would like to see your drawing in an airplane and see if it's any better than mine. Okay, so those are seats in our airplane. And the first thing you want to do is we're trying to answer each of those questions, A, B, C, and D, using our 5 different sampling methods. So I'm just going to write right here, let's see, I'll do A, B, C, and D. Okay? So the first question, the first method says pick every 10th passenger as people board the plane. So you have an empty plane and people are coming in, giving their ticket, and the flight attendant picks every 10th person. What type of sampling would that be? You are correct. Systematic. Okay, we systematically chose every 10th person. Let's try the B. From the boarding list, randomly choose 5 people flying first class and 25 of the other passengers. All right, so usually flights are separated into 2 or 3 groups, right? There's like a first class business, there might be like a premium and an economy for the common folk. All right, so in my airplane, there's only 2 types. So it's saying, let's choose 5 from here and 25 from here. Because when we just did our systematic sampling, right now, the stewardess, every 10th person, is it possible that we only got people sitting in economy level? Is it possible we only got people sitting in first class? Yes, right? So we want to ensure we get a little bit from here and a little bit from here. Think of that chocolate cake, okay? Claim jumper. You want a little bit of everything. Doesn't have to be proportional. That's a key thing right here. When I chose my grade levels here, I'm not saying I need the same amount from each one. Okay, that's not a criteria of stratified. Okay, so good job. This would be stratified. Okay, class. I hope you guys can read my handwriting. C, randomly generate 30 seat numbers and survey the passengers who sit there. Again, so we're just going to randomly generate the seat numbers and we're just going to ask those 30 people. So that would be a simple random sample. We can use a random number generator to do that. And then lastly, randomly select a seat position and then survey all the passengers sitting in those seats, okay? So what this is saying is, let's choose the middle seat. Let's choose everyone that sits here, okay? So what we just did is, yes, we were able to get part of this strata and part of this strata, right? But this group is already grouped together. The middle aisle people are already grouped together. So this is what we call a cluster sample, okay, cluster sampling. I hope you see the difference between cluster and stratify. But again, we will talk more about this on Monday during class, okay? I hope this is good to get you going, all right? Please read your textbook, all right? There are going to be things that show up on your tests and quizzes, things that I don't talk about but are actually in your textbook. So please read that. Thanks, guys.